This is 2015, number 2, which is also a calculator question. It says, let f and g be the functions defined by f of x equals this function and g of x equals this function. You can see a graph of it up above. It says, let r and s be the two regions enclosed by the graphs of f and g in the figure above. So you can see region r and you can see region s. Now again, a lot of these we cannot do yet. Part A, find the sum of the areas of the regions. We don't know how to do that until second semester. S wants to know that it's the base of a solid, find the volume. We don't know how to do that until second semester. Part C, it says let h be the vertical distance between the graphs of f and g in region S. So here's region S. They want to know the vertical distance between these two functions. So here is the vertical distance between these two functions. Now notice that it changes. Over here, that distance is a lot smaller. Here it's bigger. Here it looks like it's at its maximum point. So this is the longest distance. Alright, and then over here it gets to 0, and over here it gets to 0. So obviously the vertical distance h is constantly changing depending on what x value you're looking at. If you're looking at x value here, it's really long. If you're looking at this x value, it's not as long. If you're looking at this x value, it's getting even shorter. So the distance h is changing based on what x value you're looking at. It says, find the rate. Ooh, I love that word, rate. Find the rate at which h changes with respect to x when x equals 1.8. So rate at which h changes with respect to x, those little keywords, with respect to x. So I'm looking for dh, the rate at which h is changing, the height of that line, dx, the rate at which h is changing with respect to x. That's what I'm looking for, dh, dx. So here's how we figure out this. H, how do we figure out an equation that relates h to these two functions, all right? Well, I think graphing the functions in our graphing calculator will probably be helpful. So let me come back over here to our graphing calculator, and let's graph these two functions in them. So we have 1 plus x plus e to the power of x squared minus 2x. All right, so there's our first function, and then our second function is going to be x to the 4th power minus 6.5x squared plus 6x plus 2. And then let's graph them to see what they look like. So here it starts to graph them. All right, so there's the first function, and is it going to come? There's our second function. All right, so you can kind of see it's zoomed out pretty far, but you can kind of see the relationship between these two pictures, all right? So if you zoomed in a little further, you would probably see that here's the first region and here's the second region, S, that we're talking about. So let me zoom in more just so you guys can see this. So let's see if it can graph it again for us. Again, it's not necessary to do this, but it is helpful to kind of visualize it in a better way. All right, perfect. And again, it still doesn't look perfectly compared to this one, but our y values are not necessarily the same. So here's the region S we're talking about, and I want to know what function is on top. So I'm just going to push trace, and I'm going to come over here to this region, and the function that's on top is this function, 1 plus x plus e to this power. So it's the one with the exponential in it. All right, so this is the f of x function, and this is the g of x function. So the purpose of me graphing it is that's all I wanted to know. What is f of x on top, and that g of x is on the bottom. So here's how we can write an equation for this height. This height is going to be wherever f of x is, so whatever the height of f of x is, whatever y value this is at, minus this g of x function. For example, let's just say that this is the point, and I'm totally making this up. I have no idea what point this is. But let's just say this is the point 2, 3. And this down here is the point 2, 1. If I want to know the distance between these 2 points, it's going to be the difference in their y values. So 3 minus 1, which would be 2. And that leaves me with the length between these 2 points, or the distance between these 2 points. So if I take the f of x function, whatever y value it is at different values of x, and subtract the g of x function, whatever the y value is at different values of g, I get that h equals the top function, f of x, minus the bottom function, which is g of x. All right, and then I'm looking for dh dx, so I need to take the derivative of this function with respect to x. So dh dx, this is the derivative, equals the derivative of f of x with respect to x is f prime of x. And the derivative of g of x with respect to x is g prime of x. All right, and we are evaluating it at this value, at x equals 1.8. So let's take f prime of 1.8 and subtract g prime of 1.8. So there's a couple different ways you could do this, but I think the easiest way to do it is to find the derivatives on the graphs. So of this first function, all right, we have this first function up here, which is f of x. I'm going to find the derivative of that function. So I'm going to go to second calc and go to dy dx, which is the sixth option. And I want to know what is the derivative at 1.8. And it's 2.116. Remember to round to 3 decimal places. And then I come over here to this one, and I say g prime of 1.8. All right, great. Let's figure out the next one. So now notice that let's go back to trace. I want to jump down to this function, okay? So see me jump down to this function, and now I'm on this other one. I'm on the x to the fourth polynomial. So I say, okay, now tell me the derivative at 1.8 for this function. Oops, not that one. Second calc derivative of this one at 1.8. So this, look at my little star down here on this function. It says dy dx, the derivative of that function at 1.8 is 5.928. So the derivative of the first function at 1.8 of the top function is 2.116. The derivative of the bottom function at 1.8 is 5.928. And if I subtract those two numbers, I get 2.116 minus 5.928 equals negative 3.812. Negative 3.812. So it says, let h be the vertical distance between these two graphs. And we had that picture of that up above. Find the rate. We just found this rate, dh dx. dh dx. Find the rate at which h is changing with respect to x at this value at x equals 1.8. So we had to set up an equation for h. We had to find the derivative of that equation. We had to plug in at 1.8 and evaluate, and we got negative 3.812. And on the AP exam, this part of the question is worth 2 points. So you would get 2 points for that. That's a related rates problem, by the way. Related rates is the topic on this.